Starting with the name of Allah, the most gracious and the most merciful, a very warm welcome to everyone whoever watching out this video. First of all, before starting my presentation, I would like to express my gratitude for my mentor, Dr. Asim Ahmed, who not only inculcated the basic knowledge of the cloud computing, but also given me the opportunity to present this topic on this platform. In today's presentation, I'll be talking about what basically cloud is and how cloud is actually playing its vital role in the field of health, how the healthcare systems are being deployed using mobile phone, and what is basically the role of the cloud in the healthcare system. So I'll be talking about what is cloud computing. First of all, I'll be covering few basic details so everyone who is watching out this video will find it very easy regarding the understanding of the cloud computing, and then I'll jump how the cloud is helping in the healthcare system. So the first part, the first few 10 to 15 minutes will be covering what cloud computing is, what are the different perspectives, what are the properties and the characteristics, what services and what models are being followed, and then I'll straightforward jump uh, to the high level view of the body area sensor network. So I'll define about it what basically sensor network is, how sensor network is playing role in our daily life, and how the patients are getting treated, how the patients are getting being treated with its help. And the last part will be covering about the few technical things, what architecture is being followed if we want to deploy such a system in healthcare, and what is the protocol stack, what is a proper uh, layer to layer protocol, what protocols are being followed in such a system. So this would be the complete outline that I'll be following in this whole presentation. So without wasting much time, let's cover a few very basic things like what is cloud computing. So if we talk about the cloud computing, I've taken this definition from a very well-known and a renowned website, that is whatis.com. So cloud computing, most of the time, whenever someone is figuring out or configuring the topologies on uh, any sort of a topological application, or he just wants to represent the internet, then there is a specific symbol which is being used for this purpose. The symbol looks like basically the cloud one. So the name was taken from such a symbol, and people were inspired if the symbol for the internet on topologies that we represent looks like a cloud, so why don't we name such technology as a cloud computing? So technology of the computing represented with the cloud. So what basically it's doing, I have just shared the reason behind using this symbol, the cloud reason behind using the name cloud. Why do we name this as a cloud? But what actually this does, it's involved. It's simply it's simply the services that are being delivered uh, to peoples for over the internet. And what are those services? Well, let's see what are those services. So let's cover uh, in what could be other possible things that would be covering in the cloud computing. So it's kind of a new way that has revolutionized the IT industry, but not it's limited to any specific technologies, covering the huge central ideas. So what are those central ideas which are being covered in the cloud computing? The first one is it's actually known as a utility computing. So if we talk about utility computing, I would like to explain this utility computing with a very simple example. That utility computing is just like a service that is provisioning. For example, service provider makes the computing resources or infrastructure management available to the customer, and customer says we would only be required only those computing resources and only those infrastructure that we actually need, and we'll only pay you the charges for specific usage rather than a flat rate. So you might have experienced like whenever you are going to buy things, and you say, okay, just charge me for only those things which I'm actually getting, which I'm actually using. I don't want to be charged for those things which I'm not using. So utility computing, it's kind of a on-demand computing. It follows to maximize the efficient use of the resource. So we can say it's related to minimize the associated cost with it. And the next central idea that lies with it is basically SOS. SOS is a service-oriented architecture. Service-oriented architecture, as the name says, it's a collection of a services. It's a simply a collection of a services, which be communicating with each other. And this service oriented architecture contains a flexible set of design principles that may be used during development, or maybe during the integration, or it actually provides suites of services that can we actually use within a business domain. So service oriented architecture, it's actually the main idea behind using this cloud computing, so that you can get a collection of a service. And the last one and the main important idea, which is basically service level agreement. So service level agreement is also very important. The reason behind is that actually it's a contract between a network service provider and a customer that that specifies the quality of a service, that what services the network service provider will actually the furnish. And 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 there are multiple things regarding this contract, what kind of contract is, what parts are actually associated with this contract. Like, it may be, you can say, it may be a up and down time ratio, it may be system throughput, it may be a response time, or it can be or it can just be anything. So everything that is associated with the agreement, you first have to actually contract with the service provider that these things will be make sure. And there are few important properties and the characteristics which are at the main glance, that cloud ensure the scalability, it ensures the elasticity, it makes sure that things will be available all of the time. It shows the reliability, interoperability is ensured, and we have to ensure that there is a high access of the content. We have to ensure the performance is optimized, and there are multiple enabling techniques that are making these things happening. The web service is playing its vital role, and the distributed computing, the parallel computing, the hardware visualization. These are all the few known techniques that are being used in the cloud computing. So these are also those computing. These are also those properties, like I have discussed, the availability. So availability and reliability ensures that there is a system tolerance, there is a fault tolerance, the system is secure, the system cannot and could not be affected by any kind of a security attack. And the performance will be optimized. How the performance will be optimized? It will involve the load balancing technique, it will involve the job scheduling, it will involve parallel processing. And also it has very important and great property, that is accessibility. Because we people are very impatient, and we always want the services to be available at every time. So there should be a thin client service, there should be uniform access, there should be a scalability. We should know how to manage a multi-tenant design system. We should know how can we automate the things, like there may be a billing system, there may be a control automation system. So we actually want these systems to be available every time. So there are sometimes client oriented requirements, sometimes there are reliability issues. So we have to make sure. So cloud is not about only a single thing that you are pushing the things over the internet is just a cloud. So cloud actually makes sure about interoperability, manageability, and it ensures how can we achieve these properties, how can we automate our computing, what could be the architecture framework that may be involved in it. So the cloud is all about these properties. So we are actually targeted in we are actually targeting these sort of the things when we talk about the cloud. So first part has been covered. The second part is going to be about service models, what service models are being used. So let's look at a very simple analogy. For example, if you are in a city and you want to, you have moved from Lahore to some other city. Let's say I have moved to Gujranwala or maybe Karachi or maybe Islamabad. And when I'll be moving there, my first and the foremost objective would be to find a home, to find a house to live in. So what will be my choice? I'll have to buy a new house. Either I'll have to buy an empty house, or either I'll require to live in a hotel. So I'll be having these options. So the first option will be I can build my own house. I can have everything, but for this, obviously I need to work hard. Or the second option is I can buy an empty house on rent purposes, on rental services, on rental basis, or maybe I can customize it as per my own requirement. And the third option is I can live in a hotel as well, and I can ask the hotel guy that just decorate my room as per my requirement. And the hotel management will be saying we do not have much options for the room decoration. We'll be offering you a very limited and reserved option. So that's a third option that I'll be having. So w- I hope everyone whoever is watching out this video will got this analogy of a house. So let's translate this analogy to our service models. So let's take this house building as a service, as a cloud computing technology. So if I want to build a new house, this model will be known as the infrastructure as a service. And if I want to buy an empty house, this will be relating to a platform as a service. And if I want to let's say if I want to live in a hotel, then this would be like software as a service. So so I hope you got an idea what service models are being followed in cloud computing. You can just simply relate with this analogy. So this is a complete technical representation of these service models. So what is being shown here, if you look at here, then it shows that there may be people who just want platform as a services, and there may be people who just want software as a service, and there may be maybe few of individuals who just want the infrastructure of the services. But you can see that the software as a service is categorized as the application layer, and it is categorized as a platform, and it is categorized as an infrastructure. So if you are at a software part, then you will only be offering web-based application, mobile devices, and general application and business services. And if you want the cloud to offer you platform as a services, then they may offer you a lot of interfaces, a lot of runtime environment. And if you want the cloud to offer you infrastructure as a service, then they would be offering you maybe network storages and the different systems. So I'll talk about each services separately as well. So let's talk about the first service, which is so this one is basically the software. This one is basically infrastructure as as a service. So infrastructure, as it's very clear from the word, which is infrastructure as a service, that you are requiring, as I have given an analogy of a house. If I talk about the infrastructure, then you will be requiring the storage purposes, then you will be requiring the network services, the storage services, the servers that are offering different sort of services. You will be requiring those all capabilities. So whenever the capability is provided to the consumer, that it can provision processing, or it can provision processing with the help of storage devices, network devices, or few other computing computing resources where actually consumer can deploy and run arbitrary softwares. It can be any operating system, it can be any application. So so then this kind of a services we name it as an infrastructure as a service. The second important model was I'm just showing you the architecture. There is a lot of detail about it, but it would be a bit technical. It would be very it would be, I would say, it would be very non-technical for those which have already covered this part. So I have just covered it so that everyone, if everyone, whoever is new to this cloud computing domain, he or she may can get an idea what cloud is and what are the main actually aspects of the cloud. So if we talk about platform as a service, then the platform as a service ensures that the capability provided to the customer is to deploy onto the cloud infrastructure consumer that was acquired by the application. So they can use programming languages, they can use tools to support the provider, and these all programming languages, these all programming IDE may be provided by the provider. So because actually here the consumer doesn't have to manage or to doesn't need to control the underlying cloud infrastructure that we have seen in our last slide. He doesn't need to cover network, servers, operating system, or storage, but it has this control over the deployed applications and possibly application hosting environment configuration. You can say like Google App Engine, Hadoop, or a sector. These are some kind of the parts that we can say. Uh, so such kind of services would be known as a platform as a services. And the third and important model is basically the application one, which is very important and which has been in use by a lot of different firms, which is platform as a service. So you can say platform as a service is basically what it does is it's kind of a capability that provide to the consumer that it can deploy onto the cloud infrastructure, or consumer actually doesn't has to do a lot of things because web 2.0 have been uh, trend of using the full potential of the web. You can view internet as a computing platform. uh, we can ensure the interconnectivity of the mobile devices. We have great accessibility, we have great portability, we have web-based application, general application, business application, and scientific application, government application. We have web portals. We have so we have a lot of things to in software in this model, in this software as a service model. So till here, this was all about what basically cloud is, what are the basically the platforms, and how these platforms are actually helping the individual. So if we look at this diagram, then this is the main actually diagram of a healthcare system which is being used in the cloud. So this basin domain is basically BASN domain is basically broader area sensor network. Uh, this broader area sensor network, what is broader area sensor network? Actually, if I talk about it, then actually the wireless medical sensors are becoming very popular, and cloud computing technology is growing up. So we have a condition for the deployment of a body area sensor network. So this body area sensor network are basically the component and uh, are are considered very important means to relieve the pressure of insufficient medical resources that are getting aged, that are getting which or I should say that that insufficient medical resources and this aging era are becoming very strategic direction for the health researchers. So this system indicates that if we have an individuals which are being connected with different sensors, there may be blood pressure, body temperature. So this body will be covered with with different sort of a sensors, and they will be every walking person will kind of will be known as a sink, and it will be connected to the base station, and they would be connected through cloud. They will be connected through some gateway with the internet, and internet through the internet they will be connected with kind of service center, or maybe some sort of a cloud, and from the cloud the data will be pushed towards this doctor, or there may be some other doctor who is just watching out and who is just monitoring these all the services. So this health system is actually based on the internet of a things, the medical treatment, actually emphasizing the object management. So the concept actually adjusts the medical mobile medical technology to adapt things in this system, so the doctors, patient, medical devices, or sensors, they can all refer, they can all approach, and they can have a data in hand, and uh, they have and they have reports of the patient which are under critical condition. So actually we can name this kind of health systems are taking a very shape to this ecosphere. At this stage we have a big data era researcher that showed that data generated with the sensors are getting in petabyte level annually, and the data is getting petabyte levels annually. So we have any electronic health recording setup for these other people, then you can't believe that this medical cloud system can reduce the cost of actually medical information by just providing a foundation for storing them and mining of the big data, which with a high availability, expansibility, and the performance of the data storages. So I hope the main idea for the main we can say the main reason for using this cloud for in a medical healthcare would involve the rapid, or would involve the high availability of the data at a at the hand of the doctor, and the data will be stored in a separate log as well. So the next thing is this is kind of architecture, uh, an architecture which is being deployed here, and this architecture showing basin. Now the basin actually it's showing the same detail, but a few more additional things, like we have divided it into different tires. You can see the first tire, which is a medical sensor tire. So medical sensor tire contains the number of wireless medical sensors. It may be oximeter, it may be, we can see it may be oxygen meter, not oxygen meter, sorry, it may be a pulse oximeter, it may be heart rate monitor, it may be a blood pressure monitor, or it can be a thermometer, any kind of thermometer. It can be a weighing scale, it can be a simple glucose meter. So these are all basically plug in and play. They are all connected in such a way that they only require to operate in a plug and play manner. So these all sensors are actually using Bluetooth or Zigbee for the communication, and the standard we are following is basically IEEE, and they all will be connected with a personal gateway, and there will be a software agent operating on the phone that periodically will be collecting the data from the sensors, and will send it personalized message to log data node in case of emergency, and the message will be containing the medical parameters. uh, they may be maybe IP address, there may be user location, the medical device information. So such sort of a things will be included here, and these all will be pushing and will be collected in a defined scheduling algorithm, and it will all be generating medical care instruction statement which will be sent back to the patients. So the medical care, we must say, medical care contents are actually very personalized and customized to best build suit each mobile application. So so that's why the mobile is actually preferred in this scenario. So if we look at this diagram shows the uh, detail how the cloud is actually being deployed in this scenario, and this cloud is basically using this diagram. Actually, I have this system design. This is a cloud architecture, and we have taken this cloud architecture using the Hadoop one. The Hadoop is also included, so it says we have a messages, and the messages are actually being passed in the form of a queue, and there is a storm that is devising, and every message is being monitored, and there are files, and there is a data, and there is a hive in it, which is actually checking out these things that and actually making sure that things are stored here, and sorry, so it's kind of a process of building the expert fitness diagnosis. You can say expert fitness. It would be a kind of automatic classification system. It has a set of classifiers, learning phase. It extracts the data and then sent it. And these sort of things, this systems basically uh, mm, it's containing. Uh, then we have the last but not the least, which is basically a domain information model. And it's a protocol stack for the sensor node. So the first is basically domain information model. It's kind of the agent which is expressed as a set of objects, and each object has one or more attributes, and then attributes will be used to describe medical data, which will be sent to the manager by the agent. And so this next is basically the service model. We can say the SM model. What it does is actually define a flexible and an efficient way for an agent to send configuration information to the manager. And the last protocol step will be the communication. It defines the topological structures. Uh, and to enable one or more agents to connect to in a point to point fashion. So these are basically these three layers. It's kind of a medical domain information model would be kind of a personal health device. It will be containing the mattress, and it will be containing the segment scanner, numeric enumeration, and these all things will be happening in the service model. It will be containing all those kind of the services for the association, for the event updation, get set. So all those services will be performed at this layer of the protocol, and the third one will be the communication model. And this third last part, we would say this third last part is just to show you that how CAF how we are actually using the different other modules in our cloud computing part, which may we have heard it with Hadoop as well, or we can say we have might have heard the word Kafka. So this part, this is a Kafka that performs as a buffer role between the web server. So the message producer, that the message are which are being produced through the temperature sensor, maybe through the pulse data, maybe through the blood pressure data. These are our the messages. These are all sent to a message producer, and message producer is nothing but just a Java written Tomcat server. The producer then processes the data in an asynchronous and non-blocking way, and then after receiving the data from the Android client, the producer would first cache it in the memory, and after caching it in the memory, it will be triggering some movement or number of the messages, the pre-configured threshold, and then it will send all messages in a we can say in a batch. All messages will be sent to the specific sensors, and then the data from these sensors will be connected. So we measure the data. We have a log. We have a we have a temperature log, and then we are actually connecting and collecting all these data, and then all this data uh, will be pushing towards actually the log. So the Kafka system, we have seen how the Kafka system is involved here. And the last and the most important part of this whole presentation, that how it is being how the cloud computing is playing role in its application. So this is our presentation layer, the main layer, where we'll be using all these services through browser, maybe through portal, through messages. And at the second layer, we have customer service layer that will alter information for us. User information will be available. The secure layer, where every sort of business administration repositories will be available. These are the technical cloud part which will be available here. And then we have mobile terminal layer, and the last part, the last from top to bottom, is basically the personal health health devices. So we have already seen this. So this is how the cloud is actually playing its vital role in the healthcare industry. So I hope I have delivered what I actually targeted. So thank you so much.